So, a very good afternoon to all. The series of book discussion that will commence on 29th of November continues regularly and is being held as per schedule under the able guidance of our leadership and our Director Faculty Development Cell, Dr. Amit Kumar Srivastava sir. In this series, today's discussion is dedicated to the book titled Strength of Material, which is jointly authored by Professor Uday Shankar Dikshit sir, who is a professor at Indian Institute of Technology, Guwahati. Sir is very much here. Dr. Nelson Muthu, again from IIT Guwahati, and Dr. S.M. Kamal from Tezpur University, Assam. So, like ever, for the welcome address, I would request Director Faculty Development Cell, Dr. Amit Kumar Srivastava sir, for kindly deliver the welcome address and also let us know the objective of this book discussion, please. Thank you.
Thank you so much, Dr. Tiwari. It's my great honor and privilege to welcome the distinguished academicians in today's book discussions on the book Strength of Materials. Professor Uday Shankar Dikshit from IIT Guwahati, along with Dr. Nelson Buthu from IIT Guwahati and Dr. S.M. Kamal from Tezpur University, Tezpur, Assam. We also welcome the reviewer of the book, Professor S.P. Harsa from IIT Roorkee, who has also played a significant role as a reviewer for this particular book. In brief, I just want to inform all the faculty members and the students, we welcome you in the today meeting and wish to inform you that AICT has initiated the technical book writing last year with the basic objective to provide technical books in different Indian languages. So across India, we have requested the distinguished academicians from different Indian Institute of Technology, IITs, along with the NITs and the other central government universities to be part of this AICT endeavor. And subsequently, we have got lots of support and encouragement also from the faculty members across the different IITs. And we are happy to share with all of you that with the hard work, dedication, and time-bound commitment of the faculties from the different IITs, we are able to complete number of books in the second year. There are total 42 books at the degree level in the second year and 46 at the diploma level. And so far, AICT has completed around 32 books, and we are hopeful that by the February end, most of the books will be completed and subsequently uploaded on the portal. One of the unique feature of all these books are these are the outcome-based education books in alignment with the National Education Policy 2020, and all these books are being uploaded gradually on the eCumbh portal, which is a knowledge unleashed in multiple Bharatiya language, which has been which was launched by the Honorable President of India in November 2022 in Bhubaneswar, and we are getting very encouraging response from our stakeholder, faculty member and students who are regularly visiting this particular portal and downloading the various books. Since its launch in November, there are more than 4.5 lakh students and the faculty members visited this particular portal, and thousands of books which have been uploaded. I mean, thousand number of times our books have been downloaded by this particular with the help of this particular portal. So there are number of books. The today book is also uploaded on this portal. It's the Strength of Materials. So far, 717 students and the faculty members have downloaded this particular books, and they are using it in their program of study. I request all the stakeholders, especially the students and the faculty members, to kindly access these quality material developed by the different faculty from the Indian Institute of Technology and the NITs and use them for their course of study. At the same time, I also wish to inform all of you that recently ICT took a major decision that all these second year books are open educational resources. So any institutions, either in India or outside also, they may use it freely without any charges and as a OER resources in alignment with the Creative Commons license. So with this, I again welcome the distinguished academicians for the today interaction, Professor Uday sir, along with Dr. Nelson and Dr. S.M. Kamal, and Professor S.P. Harsha in the today book discussion. And we are quite much hopeful that the wisdom and the knowledge of Professor Dikshit sir, along with other team members, will help our student also to enrich their knowledge of the with the help of the book of Strength of Materials. So thank you, Dr. Tiwari. Now we proceed with the next.
Thank you for the welcome address, sir, and for letting us know exactly the way e-com portal is regularly and on daily basis gaining great popularity. Thank you, sir. So moving ahead for to know the salient features of the book today to be discussed, the strength of materials. The esteemed academicians who have authored it are very much present here. May I kindly request Professor Uday Shankar Dikshit from IIT Guwahati, Dr. Nelson Muthu, Indian Institute of Technology Guwahati, and Dr. S.M. Kamal, Tezpur University, Assam. So kindly over to you, sir, Professor Uday Shankar Dikshit, sir, and your team, sir, for
Okay.
letting us know the features of this book, please. Thank you, sir.
Okay. Thank you, Dr. Amit Srivastav and Tiwari ji, for giving us an opportunity to participate in this book discussion. At the outset, in fact, I would like to express thanks to AICT for launching this wonderful initiative, because in engineering education, there is a lot of disparity between various institutes, particularly IITs and NITs. They are autonomous institute. They teach this one, but other colleges, there is a gap. Even in the textbooks, there was a serious gap actually. Suppose the strength of materials is a very old course. It is more than 100-year-old course, but type of books which IIT students study and the type of books which other engineering college students study, they are quite different. But now we no longer can stay in the compartments, and it is the time that we have to come together, because we know that even though I am in IIT, but at postgraduate level, we get the students from other engineering colleges. So what happens that the style and approach of those colleges was quite different. As Dr. Srivastav has mentioned, that outcome-based education and this one. So these type of things were not there in those colleges first. AICT took a lot of initiative, and then they are trying to bridge the gap. So talking about the strength of materials, we have a lot of books in the market, but some books are, they follow only very practical type of engineering approach, and they do not care about the basic fundamentals. Even if we say that, suppose what is the stress, okay, so at school level, as you know, that education is more or less uniform. So they are, up to 12th, they are studied the definition, force divided by area, and this concept goes on even when they come for PG studies. Then they do not know that how to define stress at a point. Whereas IIT students, they are able to do that, but many of the IIT students, if you ask them to solve the problem in the conventional way or engineering approach, they are also, they used to lack. So therefore, there was a challenging task to combine everything. There are a lot of books on strength of material, and some of them we have listed in our references also, even book by Sames and all these things. But those books are having number of pages, number of examples, number of chapters, and a student, particularly if he wants to do self-study, then he will find very difficulty. So basically, whole task has been of our team has been the optimization. We try to optimize, something like madhyam mark, that how to take the good features from everywhere. So on one hand, we have to give practical examples, because these men are mechanical and civil engineers. Mechanical civil engineers are the 4th semester. So they have to study this book. We have to naturally give those type of examples. Okay, suppose there is a beam and there is a deflection of the beam, load is coming, what will be the deflection? But at the same time, we also have to teach some basic fundamentals, so that if they want to do some advanced courses, then these fundamentals can be useful to them. So that is one thing. Similarly, in the number of problems also, we have to see that we have to give optimum number of problems. If we give, suppose in one chapter, if we give 50, 60 exercise problems, then students, they don't know how many they have to practice. So we have selected very carefully optimum number of problems so that they can practice. Even if they can, for each chapter, they get a good amount of assignment, and if student can solve those problems, then their purpose is solved. We have also, in fact, credit goes to AICT because they requested me also to include basically some no more section. So there we also have added basically links so that people can go through that and they can study further. That type of thing also has been done. That is for additional study. But the book is self-contained. In the book, if a student follows that book, he will be able to complete one semester course very smoothly. And not only that, in various competitive examinations also, they will be able to do it very successfully. So these are the main features of the books. We have tried to write that basic definitions very carefully. Even say, for example, one example, if you ask any student, because maybe there are some faculty members and students sitting, they know that if you ask any student that defines shear strain, most of the students will not be able to define it properly. Why? Because they only think they can define direct strain, that change in length divided by initial length, but they are not able to tell about the shear strain, and they start making some diagram and confusing, whereas the definition is very simple, that at a point you make two orthogonal lines at 90 degree, and then see the change in angle, express it in radian, and for small strain, this is a definition of the shear strain. So like that, many things are quite simple, but when they used to see the bulk of the material, some books will be very thick. They can act as a good reference book, but not as a good textbook. So therefore, this book has been made which can serve as a good textbook. And this I like this initiative also. In fact, I have published many books from Springer and CRC Press and other, even McGraw-Hill Education. But they have put these books on their e-portal, and they are free. So in fact, I'm very happy that more than 700 people have already downloaded that book and they started using it. That should be the approach. And later on, if somebody wants to make print version, of course they can take print version or they can make their own printout, but it should be accessible to all the persons in this one India. And of course, many persons have requested me that they are ready to translate it. Even from IIT Indore, one professor met. He said, "Sir, I want to translate it in Tamil. If you happen to, if they ask," I said, "Okay. If the IICT asks my opinion, then I recommend your name. You can translate it in Tamil. Similarly, other languages also it can be translated." So this is a good initiative. And now, after telling this thing, I will ask my colleague, Dr. Nelson Muthu, to formally present the salient features of the book through PPT slides, actually. So, and after his presentation, then third author, Dr. Kamal, can also say something about the book. Okay. So, Dr. Nelson Muthu, you can share your slides and tell the chapter-wise the features of the book. You can tell. Okay. Yeah.
Thank you. So I'll just share the slides. I hope you are able to see the slide.
Yeah, it's visible.
Okay. It's visible, right?
Yeah, Nelson, you go ahead. Yeah, it's fine.
Yeah. Okay. So, first of all, I thank you, Dr. Amit Kumar Srivastava and Dr. Tiwari ji, for this wonderful initiative. the book on strength of materials. We are three authors, Professor Uday Shankar Dikshit from IIT Guwahati, myself, Dr. Nelson Muthu, and Dr. S.M. Kamal from Tejpur University. The book was reviewed by Professor S.P. Harsha from IIT Roorkee. So this is how the cover page of the book looks like. You can see it. Basically, this is the picture that we have taken just outside our campus, which is very relevant from strength of materials point of view. And the book has two coordinators, Dr. Amit Kumar Srivastava and Mr. Sanjay Das from AICT. So this strength of materials, it is also called as solid mechanics or mechanics of materials. Basically, in market, you will find many textbooks under these tags, solid mechanics and mechanics of materials. It is a next level course to engineering mechanics for both mechanical and civil engineers. So this is an extension to engineering mechanics. In engineering mechanics, we study about rigid body mechanics, whereas in strength of materials, we understand the mechanics of deformation, or it is a deformable body mechanics. Specifically, it pertains to determining stresses, strains, and displacements in different structural members. So in this book, we have taken effort to actually learn the concepts and solve the problems using pen and paper. But as with this book as foundation, you can move ahead and solve some complex problems with the help of computers. But this is the basics. These are very much required for anyone who want to understand the mechanics of body that undergoes deformation. So what is the uniqueness of this book? Basically, there are certain USPs of this book. One is that the concept of stress tensor, it is explained from a 3D point of view in a very lucid manner. In fact, if you see the chapter 1 and chapter 2, the way the stress concept itself has been defined is from bottom-top approach, in the sense, first we talk about 1D state of stress and gradually we take it to 3D state of stress. And by the time you are introduced to these concepts, you are very much familiar, you understand how things are very different from scalar to vector to tensor. So that sort of understanding has been given from chapter 1 to chapter 2 with the help of very nice examples. At the end of each and every chapter, we have given practice problems, and these practice problems are selected in such a way that they are there to maximize the learning curve of the student. So it is not many number of practice problems, or it is not too less. So we have given sufficient number of practice problems. At the top of it, we also have given example problems which will help in furthering the understanding of the concepts that any reader would read. Attempt has been made to keep the example problems straightforward. That way, whatever concepts has been read, so that way immediately a student can actually solve the example problems and he can actually reinforce the concepts very quickly. So this book is designed for one semester course. Plus, there are high quality images. A lot of images are presented in the book. As you go to chapter 8, you will see that 3D images, in the sense they have been given from a different perspective, so that students will be able to easily visualize what the book has been talking about. And it also contains multiple choice questions. So that way students can also prepare themselves for any competitive exam. And select multiple choices have been given so that students can think, and that will help in even furthering the understanding of the concepts. So these are some of the unique points of the book. Importantly, this book is based on outcome-based education. There are two sets of outcomes. Basically, you can see here, there is one set of outcomes for civil engineering students, another set of outcomes for mechanical engineering students. Actually, both are same only. So based on these outcomes, the book has been designed. The content and the presentation, the explanation are all based with respect to achieving this course outcomes. So if you look at the chapter 1, as I have already mentioned to you before, some of the things, unique things is the description of the concept of stress, particularly with emphasis of stress in axially loaded bars. And then we have also talked about concept of strain. For isotropic materials, we have talked about these material properties, elastic moduli and Poisson's ratio. And we have also given some introduction on thermal stresses and the concept of strain energy. So in this chapter, specifically, we have addressed problems with regard to 1D state of stress. If you can see here, Professor Dikshits are already mentioned in the elementary, the 11th and 12th. People would have understood stress as force by area. But here, we actually have an imaginary vertical cutting plane. So that is very important. Stress is always defined with respect to a cutting plane and also the direction along which it is acting. So that is the change in the perspective of how we can understand stress from a tensor point of view. So here in the chapter 1, we cover the 1D state of stress, and also the concept of strain also has been explained very nicely. And gradually move to chapter 2, where we have introduced 3D state of stress. And particularly in the chapter 2, what is very important is the transformation of stresses. While students can easily relate to transformation of vectors, whenever there are two sets of reference axes, when you move from one reference axis to another reference axis, how does the coordinates change? So also here, it is very important when you see from one reference axis, what is the components of stresses. When you change the reference axis, how does the components of stresses change? So that is very important, because any material that you design or any structural member that you design, they have to withstand the load without failing. Intuitively, you may feel that the material may fail in this particular point along this direction, but it is not always so. Therefore, it is very important to calculate stresses at various directions. And transformation of stresses, inevitably, in solid mechanics courses, from the beginning towards the end, even in the advanced courses, you will hear this transformation of stresses and also strains. So transformation of stresses and strains are very important, and here particularly we have given a lot of emphasis on Mohr circle of stress. This is one way of actually achieving this transformation of stresses. And we have also introduced the concept of we have also talked about the concept of principal axis of strain, principal strains, principal stresses, principal planes, and we have also talked about the relationship between different elastic constants for isotropic materials. So these are some of the salient points in chapter 2. Coming to chapter 3, shear force and bending moment diagrams. This is something you must be familiar of, at least in engineering mechanics. In certain colleges, we have already been introduced to finding shear force diagram and bending moment diagram. So here, again, we further emphasize for different scenarios, a simply supported beam, cantilever beam, beams that are overhanging, prop cantilever beams. So many examples have been considered for different kinds of loading: uniform distributed loading, uniform varying loading, and also concentrated loading and moments. For all these scenarios, effort has been taken to explain how we can draw shear force diagram and bending moment diagram. So here is one example. You have this 4-point bending scenario, and you can see there is a shear force diagram. Interestingly, between point C and D, there is no shear force, but you have non-zero moment here. So this is even if you look at the diagrams, they have been effort has been taken to present in such a way that students can learn many things in one diagram itself. And in chapter 4, immediately after shear force and bending moment, it is followed by determining the bending stresses whenever beam is subjected to loading. So this is very important from a practical point of view for civil and mechanical engineers. If you see any building, you have this overhanging beams, which are like beam-like structures, and it is withstanding some load, structural load. And you have to design, if you want to design such beams, you have to understand what is the bending stresses. If the bending stresses at some point exceed the failure strength of the material, then it is dangerous. Therefore, in such scenario, we have to find what is going to be the stresses due to bending. And if you look at the bending stresses, they are very easy to be determined using pen and paper. Actually, any problem in the world is three-dimensional, but here, we see that the stresses, there's only one component of stress is that sigma xx along x-axis. So that is very interesting. So we have approximated, as engineers, we are good. We have to be actually good. We have to actually approximate the problem, because if you have to solve this 3D problem, it is going to take a lot of time using pen and paper. But then this sort of approximation is going to be useful for engineers, and it is mostly accurate for most practical problems. So here the emphasis is on determining the flexural stresses or bending stresses. Particularly we determine the neutral axis. Neutral axis that plane, neutral surface plane, which is not subjected to any stress. And we have given a lot of attention to various cross sections. The beam can have solid cross section, I section, T section, angle and channel sections. It can also have rectangle sections, circular sections, solid and hollow sections as well. So all these particular examples with a lot of images have been given to further the understanding of the student. In chapter 5, in addition to bending stress is what we have seen in chapter 4, shear stress, determination of shear stress is also important. While calculating the beam deflection, sometimes we neglect shear stress because they are not very prominent. But there are scenarios where we have to take shear stress into account as well. And we have taken some beam sections, which are whose cross sections are very popular, or that which is available in the market: rectangle section, circular section, triangular section, I and T section. So you can see here there is one T section that is given to you on this slide. You can also see how the shear stress is varying. Suddenly there is a jump at the junction. So that way students will be able to immediately relate what is happening at this junction. So you can see these are so we have actually here introduced the formula for the shear stress distribution, and then we have also drawn the diagrams how the shear stress is going to vary for different kinds of beam sections. So actually these are some of the salient points that I have talked about from chapter 1 to chapter 5. Now I request Dr. SM Kamal to talk more his experience, and also he can present some aspects from chapter 6 to chapter 8 as well.
Okay, thank you, Dr. Nelson. Hope I am audible.
Yes, you're audible.
So can I share my own slide, means so that I can
Yes. Yeah, okay.
present from chapter 6. Hope my slides are visible.
Not yet. I think it is. Are you sharing it?
Yeah,
With
sir,
that
I am saying.
option?
It's visible now.
Okay, fine. Yes, okay.
I think there is
Here
a
it
lag.
is not. Maybe, yeah.
Okay. So at the outset,
Dr. Kamal, please click on the full screen.
here it is full screen only. So let me.
Okay.
Sir, I think this is the previous slide that Dr. Nelson was presenting.
No, slides are same.
Slides are
Okay,
same,
now
but I
it's
will
fine.
continue from
Yes.
chapter 6.
Yeah.
Yeah. Just click on this icon and
Yes.
then please go ahead.
In my system, it is slide presentation mode only. But
Okay. Then please go ahead. Please go ahead.
let me first answer it and then share the.
Yeah, it is coming. I think some was showing SK Kamal is starting to share content. Okay.
Yes, sir.
Now.
Hope now it is full screen.
It is full screen, but it's nothing is coming. Your internet is slow or what? Otherwise, just immediately you send email to Dr. Srivastav and he can upload from his side.
Or if Dr. Nelson has the same PPT, he may just.
Yeah, I'll just share it.
Yeah, please.
Yeah, you can coordinate from here. Yes. Yeah.
Okay, then let me stop sharing actually.
Yes. Yeah. Yes.
Okay.
Yes. Okay. Yeah. Yeah. Dr. Kamal, you can continue from here. Okay. Yeah. Dr. Kamal?
Yes, sir. In my screen, I cannot see. Still, it is saying that Nelson Muto
No,
is
no, no.
starting to
You
share.
see, it is
Okay.
chapter 6 is open.
Okay.
Now
Yeah,
from
yeah,
your
yeah.
screen, you speak on chapter 6, press
Okay,
right,
okay,
and
okay.
then go
Yeah,
ahead.
yeah.
Yeah,
Okay, okay, sir. Okay.
yeah. Hmm.
So, so at the outset, I take this opportunity to thank AICT for giving us this opportunity and to write this book on strength of materials. Particularly, I thank Dr. Amit Kumar Srivastavaji and Dr. Tiwari. I also thank our reviewer, Professor S.P. Horsa from IIT Roorkee. And I would like to continue from chapter 6, that is on slope and deflection of beams. So, as you know, as Dr. Nelson has mentioned, in chapter 4 and chapter 5, we have discussed actually the stresses induced in beam cross sections subjected to loading. But you know, there might be a situation in which uh, the stresses are within the limit because of the applied loading, but it may so happen that the deflection or the deformation is so excessive that the component is not in a usable state, means it is not able to perform its intended design function. So under that circumstances, it is very much important to calculate the slope and deflection of beams. For example, say if you consider the aeroplane wings, right? So if that can be considered as a cantilever beam. So if because of the applied loading, the deformation is excessive. Suppose if it is in stationary condition, because at full load condition, if the wings start touching the ground, the deformation is excessive because of the loading. So that is not actually desirable. And from that perspective, we have actually discussed the concept of slope and deflection and their determination due to the applied loading in this particular chapter 6. And you know, after when the beam is subjected to loading, the axis of the beam, that is the neutral fiber of the beam, takes the form of a curve, right? And the deflection is measured from the undeformed that axis to the deformed axis, the lateral distance, and that is basically the measure of deflection because of the applied loading. And in order to determine that, first we have actually obtained the equation, the differential equation, the governing equation of that deflection curve, and then we have actually presented the various methods to calculate the deflection and slopes in beams. So, for example, the double integration method, which is based on that differential equation of the elastic curve. And then we also introduce a graphical method to obtain the slope and deflection, that is moment area method. We have presented two theorems, as moment area theorem 1 and moment area theorem 2. And then we introduced the Macaulay method to evaluate slope and deflection. And to understand the Macaulay method, actually the understanding of singular function is important. So that aspect is also covered in this chapter, and that is referred as the Macaulay function in this particular chapter. Then we also discuss the Maxwell-Betti reciprocal relation in this chapter. So these are some salient features of this chapter 6. And then coming
Go
to chapter
chapter 7 maybe. Nelson, open the chapter 7 now. That's right. Okay, chapter 7 is
So-
there. Yeah.
In
yeah.
chapter 7, we discuss the torsion of circular shafts. So, you know, there are various examples. So, in machinery, means say circular shafts, means power transmission shafts. In service, they are subjected to torsional moment or twisting moment. And because of that applied twisting moment or torsional moment, what are the stresses coming onto that member? So, that is covered in this particular chapter. So we first derived the torsion equation using based on certain simplified assumptions, which will help students to calculate the stresses, the torsional shear stress in such members, and also to obtain the deformation, that is the angle of twisting. They can evaluate. And further, first we consider just that the member is subjected to only torsional moment. But there might be a situation where shaft or such circular members may be subjected to combined loading situation. For example, say it may be subjected to a torsional moment or an axial loading, or it may also be subjected to a bending loading. So in that case, how to obtain the stresses, means analyze the stresses and deformations in such members, that is also covered in this chapter. And where under combined loading situations, students can easily calculate the principal stresses, the maximum in-plane shear stress, etc. Using the concepts covered in the chapter 2. And then we also covered the analysis of closed coil helical springs in this chapter. So these helical springs are again very important machine element which is widely used, for example, say for the purpose of cushioning, and then for connecting some machine elements, and even in some measuring instruments this is used. And then when the spring is loaded, means usually a spring is subjected to either tension or compression, and when it is considered that the loading is acting through the axis of this spring and the coils are parallel to each other, then this is the wire is only subjected to a direct shear as well as a twisting moment. So under this twisting moment and direct shear, what is the state of stress in this in the wire of this spring? So that is discussed in this unit. And then coming to
chapter,
the
chapter
last
8
unit,
open now.
last chapter, that is chapter 8, which is on the analysis of stresses and strains in thick and thin cylindrical vessels, cylindrical as well as spherical vessels. So, the pressure vessels, they find plenty of examples, plenty of applications, a wide range of applications, from your household LPG cylinder to vessels used in oil and chemical industries, even in defense industries, the gun barrel, and then the submarine hull, then the vessels used in chemical reactor, etc. So in order to understand the stresses in those kind of cylindrical vessels, it is very important to analyze, means this will be very useful, this chapter will be very useful in finding out the stresses. And after going through this chapter, the students will first understand how do we actually distinguish between a thick and thin cylinder or sphere, and then the stresses and deformations in the thick and cylindrical as well as spherical vessels under the action of internal pressure will help them in design such pressure vessels. So this is the thing which are covered in chapter 8. I hope this entire book will be useful for students, at least in getting the fundamental concepts along with the real life application of its concepts that is covered in this book. Actually, to summarize, actually the whole book, the salient feature of the whole book can be divided into two things. First is the emphasis on basic fundamentals, and the second is the real life application of its concepts covered in this book. And the example problems in each chapter is given in such a way that just we finish one concept, particular concept, and then the example, one or two example problem is provided to understand that concept better. So that way it is designed in all chapters. And furthermore, as Professor Dixit sir has mentioned, that this book will also be useful for some competitive exams like GATE, etc. Even this book will be useful for some appearing some interviews as well for this particular subject, because a lot of short answer type questions are provided, and those questions are based on the experience that I faced in different interviews, and also some expected questions which are usually asked in the interviews. So that way those questions are designed. So we hope the students will enjoy reading this book and will be benefited. With this, I would like to conclude. Any suggestions and constructive criticisms are welcome for further improvement of this book. Thank you from my side.
Thank you, Dr. Kamal. We have with us the reviewer of the book, respected Professor S.P. Harsha sir, who is from Indian Institute of Technology, Roorkee. May I kindly request Professor Harsha for his kind address, please.
Everyone.
It is muted, I think. Professor Harsha, you are muted. You just unmute. Yeah, now it's okay, but it's very faint actually. Maybe you speak near the camera.
Okay. I think
Yeah, some adjustment.
yes. So I think now I'm audible, I guess.
Yes, yeah.
Thank
Yes,
you.
sir, audible, sir.
Thank
Yeah.
you so much, and I'm good afternoon, everyone. I'm considering myself as a fortunate to review such a wonderful book, actually such an informative book. I'm first of all thankful to Dr. Srivastav and Dr. Tiwari that for they gave me this opportunity. The important contributions made by Professor Dixit actually is our alumnus actually from IIT Roorkee, and his teammates Dr. Muthu and Dr. Kamal actually they have done a really wonderful job. As far as this book is concerned, the unique feature of this book is they explained all micro features like as rightly mentioned in the presentation that the tensor domain of stress. Most of the students, they don't understand the meaning of tensor. Though they know that it is something you see which represent the space, in the space what exactly the stress distribution is. But it is really represent the presentation of this part in this book is phenomenal. It's wonderful. Second part, which attracts me is the three-dimensional figure. It's really appealing you that you not just go and read, because you see most of the books you'll find, especially in the Indian domain which are there, they're only using 2D or sometimes the line diagram. Three-dimensional book just gives you a kind of physical feeling about that particular thing, that how actually the distributions are happening, how actually it appears in the different cross section and all. So these are the two unique features which I observed actually while going from the entire script of the book. As you know, this is one of the important subject for civil and mechanical people. So I think you see here, right from the basics of, we can say, if you go through from, the contents wise, the basic stress definitions, and then using, the important tools, just like if you go through from the text, what I observed actually that as of you are just deeping into the sea and finding something at a micro level. This is really another important thing, because you see here, most of the books which I, referred, like Crandall book, like Timoshenko book, like Popov book, they are going, but somewhere they, disconnected and they assume that the students knowing. But here, since for our undergraduate students, where the teachers are not well, we can say upgraded, this book is really wonderful for that point of view. So either from the basics of stress and strain, from all the domains, then the compound stress and the strains you see here using all kind of graphical or analytical solutions. This was wonderful for the initial 2 chapters to understand the basic phenomena from the physics point of view and some mathematical features associated with that. Then the application like the bending stresses this bending moment diagram and shear force diagram. Then we can say the flexural stresses, shearing stresses, all these are, and then finally the torsion. And the final part was there about the application of the thick and thin cylinders. So these all 8 modules were really rich in terms of information. It's well drafted. And the important part, it is rightly mentioned that there are good quality questions in MCQ. Recently, you see here, today only I came from the GATE exam, and yesterday, this mechanical paper was there. So there was, you see, since I reviewed the book, so I was constantly looking that, you see here, the questions, if somebody is, going through thoroughly from this book, probably he could attend this design aspect from solid mechanics point of view and design, machine design part. So all in all, the good numerical problems, there in the solved and unsolved part. So I really, I'm thankful to AICT as well as I'm thankful to the authors who have given, you see here, like a wonderful book to the student. Thank you very much.
Thank you so much, sir, for your valuable points and your review of this particular book. So now the session is open for any query for the participant. So I request participant, if you have any query, just raise your hand or type in the chat box so that we can take up your query with the distinguished panelist here. Any participant, if you have any query, just raise your hand or you type on the chat box also, so that the panelist may respond to your query, please. Yeah, Dr. T. Rajagopal, we have unmuted you. Yeah, please go ahead.
What? Yeah, please, yeah.
Yeah, Rajagopal. Yeah,
Yes.
please go ahead, sir.
போய் கீழே கிரவுண்டுக்கு போவீங்களாம் இந்த பிடிஏ வரோம் கிரவுண்ட்ல போய் உட்காந்து.
Dr. T. Rajagopal, if you have any query, just we have unmuted you. Please raise your query. Dr. T. Rajagopal.
அனுப்பலாம், இன்னைக்கு முதல் நாள், நாளைக்கு பேசிக்கலாங்க. என்ன கிளாஸ் எடுக்கிற மாதிரி தான் மாத்தி.
I think there is some issue at region. If any other participant has any query, please write on the chat box or raise your hand, please. Eknath Manjrekar. Mr. Eknath Manjrekar. Mr. Eknath, we have unmuted you.
Hello.
Yeah, please go ahead.
Sir, have you covered strain energy topic?
Yeah. Strain energy is covered. Yes, of course. Strain energy is covered. Yes.
Okay, and columns.
Even yes. Yes, of course. Column has not been included because it is not in the syllabus actually. No.
Okay.
That is one part which will come in the next course. Okay. Yeah.
Okay.
But strain energy and even using the strain energy, that Castigliano column, etc., those have been covered actually. Yeah.
Okay. Because in our syllabus, column part is there and strain energy also.
Yes. So yeah, but because this was the syllabus, so we designed based on the ICT syllabus, and in that it is included in the second actually
Okay.
subject. Yeah.
Okay. Thank you, sir.
That's fine. Okay.
Yeah, Mr. Balachandran P. Setti. Balachandra P. Setti. Mr. Balachandra P. Setti, any query, please?
Sir, I have some clarification with the changed scenario, sir, that the mechanical engineering admissions are not taking place adequately. How about solving the problems in strength of materials all in computer language and putting that across in the lab, in the textbook itself, so that students get attracted to this subject? So the admissions in the mechanical engineering is slowly coming down. All of mathematical equations, mathematical solutions. How about computerizing it?
Yeah. Okay. Should I respond? Okay. Dr. Rajagopal, you have asked good question. It is true that that's why it is very challenging to design the problems and attract the students. But the basics must be clear. So what we did, that we have followed that type of approach that even the students can do the problems in the computer also. And then we have put some QR codes actually in the book. Using those QR codes, the students can see the further that even some videos and some nice this type of thing. And basically, as far as this one, basic concepts are like, say, for example, the stresses, principal stresses, that you can find out from Mohr circle also, and we can find out from the eigen value also. which can be done on a computer. So these type of things have been mentioned so that the students can use them, and in order to attract them, in fact, the book is written in a very concise way, in a optimum way, considering that students will not spend that much time only on this subject. There are so many subjects. So these features we have taken. But you know, of course, that everything, if we just give that automatically by computer, then the students will not get a feel of that. So that's why that we have tried to optimize it. And otherwise, your question has to be tackled from various point of view. It's not only one problem, but we appreciate this your concern. But the thing is that we have tried to do it in that way. That means making it more attractive, writing it this one, and as told by our authors and reviewers, that basically by means of giving good diagram. Okay, so that way we are tackling this one problem. Okay, yeah.
Thank you, sir.
Okay, yes.
Thank you, sir.
So thanks for the inputs and
Tiwari, just we take the last question from Mr. Vishal Srivastava.
okay, sir.
Yeah, Mr. Vishal Srivastava.
Well, good afternoon, everyone, sir. Sir, I hope, sir, is Shear Center is covered in this book, sir?
Yes, yes. No, we are talking about this one. Unsymmetric bending is not in this syllabus actually. No, that comes in this one. Even here in IIT, we teach in the second course actually, unsymmetric bending. Okay. So that's why the Shear Center concepts will not come here. Okay, and giving, but we have of course talked about the shear stress distribution actually. No? Like you have parabolic distribution, if you have prismatic beam, like that. But other part, some of the parts actually we teach because one course is not sufficient. This is the book only designed for one semester course actually, not for 2 semester courses. Okay.
Okay, sir. Thank you, sir. If you are designing book for the second semester or the subsequent semester, please include Shear Center because very
yes.
Good literature is not available on Shear Center.
Yes, yes. In fact, the second year, three topics are very important. One is the buckling, that column instability. Another is unsymmetric bending, and as you said, that Shear Center. These topics will be covered in this part 2 of that, solid mechanics 2, basically strength of materials 2. Okay.
Yes, sir. Yes, sir.
Advanced strength of materials.
Yes.
Okay, right. Yes. Okay. Yeah.
Thank you, respected sir. We are now heading towards the concluding session. I would request my colleague, Dr. Sanjay, to please present vote of thanks.
Thank you, Tiwari. It's another great book that is available now in the public portal, that's AICTE Ecom portal, and which is definitely will go a long way to benefit all the readers across any platform who are interested, not only the related students or faculties who are in the currently studying this field. And at the end, on behalf of AICTE, I extend our heartfelt thanks to all the resource persons today. Professor Uday Shankar Dikshit sir from IIT Guwahati, Dr. Melson Mithu, IIT Guwahati, Dr. SM Kamal from Tejpur University, and also reviewer of the book, Professor SP Harsha sir from IIT Roorkee. We also are thankful to all participants who have been with us during the discussion process and raised their queries, and hopefully it has been well explained by all the resource persons. And at the end, last but not the least, our technical support persons, Ms. Jania and others who have supported the entire discussion process move on till now. Thank you all. Thank you.
Thank you so much, sir. Namaskar, sir. Thank you.
Thank you. Namaskar. Namaskar.
Thank you.
Yeah, namaskar. Okay. Okay.